All right, I guess we're ready to get started. So thanks everybody for coming. This is a great turnout. So we're really happy that y'all are here today. I want to make a special thanks to South Country Fire for hosting this event. It's a great facility. So, and I want to acknowledge Fire Marshal Tyler. Thank you for hosting. I appreciate that. And I think that we have a pretty large, wide group of folks here represented between agencies. And I think we had some builders that signed in. I'm not sure if they arrived here or not, but this is an important topic. So we're really excited to have everybody here. Housekeeping, we have everybody knows where the restrooms are. They're off to the right. We have lunch coming, so that'll be here shortly. So without further ado, we'll let the experts get to talking, and I'll get out of the way. Who's going first?
No, I'm good. Hey, good morning, everyone. I'm Mike Brownson. So I've been in the industry for, well, quite a while. And I know there's a familiar face or two out here. Anyhow, so I'm going to talk about best practices for versus inspectors. But let me start out. Did you shut it off? All right. Mr. Technology. Here. It's powered. It is not responding. It's not a point. It's the RF right here. Oh, it was working. Always. Sometimes you have to just click in the window. There you go. Thank you so much. All right. I love it when it works. So some of you might have seen or heard about this book, the Complete Ursus Handbook. It was, I'll tell you, the publisher of the Safer Buildings Coalition. Some of you may have heard them as well. They're a not-for-profit group, basically promoting safer buildings through wireless communications with a big emphasis on emergency responder enhancements. And they've been very active. I think they're in their 12th year of existence. So lacking a really good guide for both jurisdictions, code officials, contractors, installers. They wanted, a good comprehensive everything in one book. So anyhow, so they sponsored this. I am the managing editor and one of the principal authors of the handbook. And the raffle tickets that you got, somebody's going to walk away with this book. So that's what that was about. But it's literally everything you could ever want to know about, in-building radio. This stuff. Okay. Now, there's a specific chapter in the book, later in the book, that's called the acceptance test. The material in this test is predominantly out of that chapter, and it's all about, what is it? What is an acceptance test? But we'll talk more about that later. But let's talk about it now. How about the goals of acceptance testing? They're really twofold. One, does it meet the code officials and the authority having jurisdictions expectations? That means a lot of things, right? You've got the physical aspects, you've got the electrical aspects, the RF performance. And then, of course, it involves in documenting the final conditions. That's another very important part. So providing as-built, keeping the documentation in place. There is actually, and this sort of stuff is right in the code books, both IFC and NFPA, say you shall maintain documentation. All right, so we'll talk more about what that documentation looks like. But let's start out with the understanding that this stuff isn't easy. All right, I know that. We're dealing with stuff that I would not expect most code officials, firemen, public safety officials to understand. What most folks in this room probably know about two-way radio is you've got this thing, you can hold it in your hand or it's on your hip, you push a button, you wait for the beep, and you talk. If that's your total knowledge of radio communications, that's pretty normal. Well, when we're dealing with these emergency responder communication enhancement systems, which basically include, off-air antennas to pick up the signal from the outdoor network, an amplifier, a very high gain amplifier can amplify signals millions to even 1 billion times the incoming signal power, and then distribute that in the building. Well, these things have the ability to be destructive to the radio network if not properly installed. So as a code official, how in the world are you supposed to know? I'm looking at this red box in the wall. Is this going to harm my radio network? I don't know. I push the button, my radio works. Okay, so I do acknowledge it's not easy. And the FCC says that the radio licensee must get involved. Now, a lot of the licensees don't know that. It's also now in the last couple of versions of code, both IFC and NFPA. So IFC 510, NFPA 1221 or 1225 as of the 2022 version. It also says that you must get the licensee for the radio network involved in these systems as they turn up and validate that they're working and not being destructive. So codes come a long ways in helping you understand that there's another authority having jurisdiction. Not just the code official, it's the FCC license holder. We don't typically call them the HJ, but the FCC has given them authority over retransmissions of their signal. So they are actually another authority having jurisdiction. So I want to kind of simplify some things so that from your perspective, you can kind of look at something and at least have an inkling of whether or not this solution is set up correctly or not. There's a lot of new folks getting into the industry that really don't have an RF background either. Right, a lot of fire alarm integrators. They're really good at managing projects, at cabling and doing a good job physically, but without an understanding of RF, it can create additional problems. So it's complex. Understanding the radio network, RF and amplifier behaviors. And then of course, we've got all these codes that apply. So IFC 510, NFPA 72, 1221, 1225, and NFPA 70, the National Electric Code. I know you guys are not electric inspectors, but they have their part to play in this as well. One thing that you may want, that you should be observing though, is basically the fire code sections, these referenced here, say that BDA shall be permanently wired into the building to a dedicated circuit. That's kind of where your responsibility for electrical stops. Is this on a dedicated circuit? Is it hardwired? And does the circuit breaker have a lockout on it? And then your responsibility for electrical kind of stops there. Right? So we can simplify that part. And I'll add it. What makes this further even complicated is before you can even go in and do an acceptance test, the building typically has to be in that 80 to 90% complete before the ERSA's installer can even put a system in and do the testing to evaluate how much of the building needs a system. So there's a big rush right at the end for these systems. And it's often the very last system that is inspected prior to CO. So again, it's not easy. I know that. But the thing is, this is a life safety system. It's just like fire alarm and sprinklers. You know, it's put in there, it's put in the code to save lives. So we should be taking it very seriously. And NIOSH in their, you know, they always do their studies and their reports after incidents. And effective radio communications is in the top 5 in protecting first responders' safety and lives. So it's important. And then, of course, we also have the public involved as well, right? Because you're out there protecting the public. So we have them to protect as well. This is just kind of the high-end stakeholders we'll talk about, right? You know, again, we have obviously the HJ, also you guys. The radio network licensee, I already talked about that. You've got the systems integrator. They're the guys that are basically hanging stuff in the wall, pulling the cable, connecting all the antennas. They're responsible for doing the job to code and to your expectations. The building owner, the GC, the public, and there's a whole list. There's a chapter, I think chapter 3 called the stakeholders. Just touching on the most important ones. These all have a big impact on just how these systems go in and perform in the end run. Noise. Okay, I mentioned early on that these systems can cause degradation for the radio networks. So let's talk about noise, you know, and no noise. That's our goal here. Okay. All the current code, I think the last couple of revs said the BDA system, the signal booster system that is put in, shall not raise the noise floor of the radio site or the radio network. So let's talk about what that means. When we talk about noise, it's much like, you know, here in this room, okay, I'm sure you can all hear me just fine. I'm told I have a great public speaking voice. I don't need a mic. But let's take the scenario where, you know, we're on a break, everyone's chatting to their neighbors, and I'm trying to talk to Vince back there. In order for me and Vince to have a conversation, we either need to like really amp up our volume, or I need to move closer to Vince to have that conversation. Well, it's much the same in a radio network, right? So noise is unwanted RF in that frequency band or on that channel that your radio networks are operating on. Anything that's unwanted is noise. BDAs have been known to be one of those noise factors, noise creators. Improperly installed BDAs. I'm sorry, there's a little myth out there that BDAs cause noise. And I will debate that with anyone. It's not the BDA, it's the BDA installer. Okay. You can have hundreds of BDAs in one area, you know, pointed at the radio site tower, not raise the noise floor. Unless the installer's system integrator doesn't know what they're doing. And that's the problem. So let's say this scenario, and Vince and I are, you know, having a conversation. Well, thing is, your portable radio can't raise the power to be able to make that conversation happen when noise is present. So what is that? That radio, that if I want to talk to Vince while we're on a break, I got to walk over there. What's what happens to a radio network? Its coverage shrinks from covering its intended area down to covering a mile, half a mile, a couple of blocks. So basically, these can deafen the radio site so that they just can't hear the portable radios, the users, unless you're really close. All right, that's what we don't want to happen. So I'm gonna talk decibels here, but not much. All right, this is more of an illustration I want to point out. First off, noise is ever present. It was actually created. There's a background thermal noise floor that was created by the Big Bang. So physicists tell us. Either way, so there's always noise. It's at a very low level, so we're all fine. Well, what happens is these BDAs, and I don't think oh wow. That's because this is a screen. Okay, they amplify that noise. Right? That's what BDAs do. They're big RF amplifiers. You know what BDA stands for? Bidirectional. No. A big dumb amplifier. Oh. Okay, they really are. They're just a big dumb amplifier. They're really not that smart. They amplify everything. So what happens is we have this thermal noise floor that's always out there. I'm going to throw numbers. Neg 134 dBm in a 10 kilohertz channel. For any of you RF geeks out there, you got one or two or three. Okay. So the BDA is going to amplify that noise. And then, the donor antenna is going to amplify it some more. But then outdoor that free space path loss. Okay, there's a lot of loss as RF travels through space. And ideally, the noise is down here at, the reality is it's always at thermal. It never goes below. But it's at thermal or below, which doesn't exist by the time you hit the radio tower. But let's take a different scenario. Okay, this is a BDA that's correctly installed. This is a BDA that was put in close to the radio site, in this case, half a mile away, and at full gain. Right? I mentioned how much gain. Some BDAs, if it's a 2-watt BDA, they're capable of 90 dB of gain. That's a billion times amplification. It's amplifying the noise a billion times, plus a little more because there's this noise figure factor within BDAs as well. So what happens is now we have, sorry, I pushed the wrong button. My apologies. Okay, so now we have noise. In this case, neg 125. That's almost 10 dB above the thermal noise floor. The net effect of that noise is it took the radio site and reduced its range to 1/20th of its original coverage footprint. All right, that's what we don't want to happen. Now, as a code official who's not an RF expert, how do we know? All right, well, sorry, one more. Well, yeah, that's what this is. As a code official, how do we know? Well, you should ask the system integrator to log into the user interface. He has to anyways, right? Because you want to do alarm testing. You want to validate that alarms will, trigger a supervisory into the fire panel, right? So he's going to log in that anyways. Ask him to show you what the gain is set at. Uplink gain specifically, but downlink gain may be the same. I remember some while back, some years ago, I was doing a project. I was fixing a project in Lubbock, Texas, and I show up. It had already passed jurisdiction's inspection. Code official walked around, did his radio test. They thought everything was fine. And I show up, and of course it was a power problem. I didn't really need to log into the BDA, but I did anyways because it's best practice. And I found that the system integrator had left that thing to full power gain, to 90 dB. Let's see. If you see that if it's a half-watt BDA and the gain says 80, or it's a 2-watt BDA, the gain says 90, just walk away. There's no reason to do anything more. What that's telling you is that system integrator doesn't have a freaking clue. You never operate BDAs at full gain. Right, Jeff? Okay? That's a fail. What it's telling you is this guy has no clue about RF. That's probably the best way, and it's not, you shouldn't waste your time past that point. All right? The installation, the physical side may be perfect, but that BDA now has, there's two things. One, it is almost positively violating the FCC's rule, which, by the way, that's federal law on maximum radiated power off. So they're already in violation of the FCC with either of these full gains. And they may be causing a noise rise at the tower site and limiting the functionality of that tower. So I realize not everyone has, the solution like Douglas County does, where, they get involved and turn up and watch what's going on at the radio site. Most jurisdictions around the country don't have that capability. So I get it. So how can you tell if this thing was improperly installed? That's probably the easiest way. All right, just walk away and advise them that they should contract with an RF expert who has the right equipment and the knowledge to do it right. All right, they shouldn't be guessing at this. So now, so y'all get involved in a couple of stages, right? I mean, within every jurisdiction, there's going to be plan review. Which, by the way, code requires these systems get a permit, which means they're in plan review at some point. All right, so it's not an option. At plan review, there's a couple of things that should be required from the system integrators, that they provide link budgets. Now, a lot of these integrators are used to providing one link budget, which is the downlink. So in the BDA world, we call uplink downlink. We don't say transmit receive, like in the radio world. So downlink is the RF signal from the tower into the building, down to the ground. It's easy to think because towers are generally up high and they talk down. Portable radios, mobile radios, that's the uplink because they're talking from the ground up to the tower, all right? So there's two frequencies used in these radio system networks, at least two, right? You have a downlink channel and you have an uplink channel. Link budgets should be provided for 3 link budgets. The downlink signal link budget, which is, showing power out of the tower, path loss, system gain of the BDA, how much power is at each antenna. Well, that's fine. There should be an uplink link budget, which is portable radio keys up inside, hits an antenna, amplified up. What's my signal predicted at the face of that tower? And then you have a noise link budget, which is back to my picture I did there. I have thermal rate. I had thermal noise. I have my predicted uplink gain. I have a noise figure to the BDA, my path loss, and I say it must be neg 144 dBm measured in a 10 kilohertz bandwidth or less, right? The licensee, they have a lower value, 20 dB below. Yeah, right. So from a plan review perspective, I would highly suggest requiring the 3 link budgets with every permit submit. Now, if the system integrator comes back and goes, what's the link budget? As Jeff Foxworthy would say, that's a sign. He should contract with an RF knowledgeable versus knowledgeable to help them out. Okay. So from a plan review, that's where you can catch it. Require the 3 link budgets. I know you're going to look at it and you're not going to know what they're saying. But by requiring it, that's kind of that threshold. I mean, it's requiring an extra step and it's showing you whether or not the integrator has that certain level of knowledge to be able to move ahead. All right, so I spent a lot of time on noise because I think it's that important. So let's move on. Test plan requirements. So when you show up, what are you requiring in terms of how are you testing the system? So IFC 510 says every floor plate of the building should be gridded into 20 roughly square-ish, equal-ish grids, and that a test be made in the center of each grid. Now that test, for normal IFC requirements, is a delivered audio quality, DAQ test. Well, the problem is to do that, they need to have radios that operate on the radio network. I don't think anyone in this area actually provides loaner radios. Well, I could be mistaken. Okay, Douglas County does. In other words, you have to have loaner radios on basically like a test talk group. It's only used for that sort of thing to be able to do this. So when you don't offer loaner radios, there's no way they can follow code's recommendation of doing a 20 grid DAQ test. So a typical fallback is doing a signal strength test. Okay, this can be done with a variety of instruments that are readily available. A very common one is like a spectrum analyzer. Basically, it looks at the RF spectrum and it gives you a frequency and a signal strength. So you can walk around, but the trouble with those is you're only seeing the downlink signal strength. The signal strength being radiated, either coming through the walls of the building or through the BDA system out the antennas. But, hey, that's what most system integrators are doing, because most jurisdictions don't have a longer radio program. I would like to see jurisdictions come up with longer radio programs. All right. I know there's mechanics involved. It's not easy, but that's recommended because if you can talk and listen and have clear communication in both directions with two radios, that's a sure sign that the system is performing well enough to provide the audio quality which is required, which is a delivered audio quality at 3.0, which I disagree with, by the way, because that's some interference with minimal repeats. Wait, should we have to try and talk multiple times on a life safety system? So that's why I disagree with that, but you know what? That's what code says. 3.0 is a pass. Okay. But suppose you could be a little pickier about that. I get a bonk here. Well, in fact, that's clear. If they're standing approximately center of grid and they get a bonk on the radio, that's a failed grid. You cannot move. This is code. Code says you cannot try again in that grid. All right, so that's one failed grid. You can have you can only have one failed grid for that floor to pass. If it bonks or you get inaudible communications on two grids, that is a fail of that floor. That's you fail them, you finish your inspection, you have to get it right, and reschedule an inspection. All right. So I mean these are the sort of things, when you can just say, well, we follow IFC OTB 2021, IFC 510 2021, and they can go strictly by that. Right? But you also have to then go strictly by that. If you have local amendments, if you got different variations or something else you're looking for, IFC 510 2021 references NFPA 1221 for design and performance. Well, the performance part of it talks about critical area coverage. Until NFPA 1225, the critical areas did not include the elevator cap. But as the jurisdiction, you can require elevator cap coverage. And even though it's not in the code, but you want to tell your system integrators that I'm requiring elevator cap coverage. Because if you just say we're following IFC 510 2021 version, that doesn't include elevators. It includes elevator lobbies, standpipes, fire control room, all the usual critical areas. Personally, I really like the idea of elevator coverage. If it's not a fire, using the elevator all the time. Who else uses the elevator? EMS, police. Wouldn't they like to have communication? Anyway, so clearly communicate what the requirement is. If you're looking at signal strength, which is also known as RSSI, received signal strength indicator, what is that level? Neg 95 dBm has been a very common number in code. The annex of 1225 now says that neg 100 is actually a pretty good level, is a passing level for digital radio networks, which is all we have here. All right. So you could use a neg 100. In other words, let them know what your threshold is. So that when they test, they can test to the proper thresholds. I think it's very important to communicate ahead of time. What is your expectation? The other thing we see a lot are cable pathways. Is any conduit required on any pathway? Now, the interesting thing, since 2016, cable protection hasn't really been in the fire code sections of the code, except for, basically it says go to National Electric Code for pathway protection from mechanical perspective. Which NEC in section 800 for communication system basically says if the cable is exposed to damage, parking garage is a great example of that. Some open ceiling spaces, it should be mechanical protected. Other than that, there's no conduit requirement in other areas. I mean, I'm getting kind of broad here, but going in general. Now, fire rated pathways, that's a whole nother deal. All right, we don't have that really nice, cool, CI rated fire alarm cable that the fire alarm guys do. There is a 2-hour rated cable, but the thing is, the bits that go in between to connect signal to an antenna, none of those are fire rated. Right? So just using 2-hour cable without also protecting the bits in between, what we call the splitters, couplers, tappers, that is now not a 2-hour rated pathway. It also gets a little more complicated than that, in that, okay, so rated fire protected pathways are going to be a portion, they're talked about in the NFPA. Since IFC, what was it, 2018, sorry, IFC 2018 says that use NFPA 1221 for design and performance. So anyone that's following the 2018 or later version of IFC, got to go to NFPA for those aspects, specifically the ERSA's part, not NFPA 72 necessarily, right? Anyway, fire rated pathways gets interesting because there's been a lot of confusion over time, but I'm going to talk about it at a high level, just a little bit. There's also a really great paper that was released. So chapter 5 of this book is called Codes and Standards. It was written by Chief Alan Purdue, retired. He's on the committees, the voting committees for 1221, 1225, IFC 510, and a whole bunch of other stuff. He's a very active individual. He's also the executive director of Safe Buildings Coalition. He wrote chapter 5. There's a section that's available to you all. I should have thought about how to be able to get that. You can just reach out to Castle Rock, myself, in case they have my contact info. But it's several pages out of the handbook, specifically dealing with the intricacies of fire rated pathways. In short, if it's a high rise, you are in a rated pathway. Okay, generally in high rise, you're going to have a 2 or 3 hour structural frame rating. So that's the requirement. Although radio code, ERSA's code says no more than 2 hours. So basically you have to put in a 2-hour chase or 2-hour cable, be compliant. If it is not a high rise, then you look at the building's primary structural fire rating to determine is any fire rated pathway required. Unless that building is sprinklered to NFPA 13, no fire rated is required in the backbone. Right, that's what code is saying now. So it's gotten a lot clearer. Sorry?
Sprinkler building.
And to NFPA 13. Correct. Okay. Now, I think they kind of missed something because there's also 13R. It's not, code doesn't say 13R now. They're working on 2027 version. 13R will be included in the 2027 version of NFPA 1225. So I think the intent was there, but they kind of like, whoops, what do we do with 13R? Which again, you have that opportunity or that option as code official to say, oh, we'll let 13R pass. The idea, if it's a sprinkler building, history has shown the fire rarely spreads, like very rarely, like depending on the building type, somewhere between 5 and 8% of the time where the fire spreads outside the point of origin. So why are we worried about graded pathways in a sprinkler building? Right? Unless that point of origin is in the riser closet, which is probably one of the least likely places for it. So they're trying to build a lot more common sense into the code. So like I said, there's a whole paper on this that's available, basically about rated fire, fire rated, and talks a little bit about the mechanical stuff too. So there's two aspects of this acceptance testing. Okay, there's systems installed, you're going out and verifying the physical, right? Is the BDA hardwired? Lockout on the breaker, conduit exposed areas, red box hanging on the wall in a, I try to remember exactly what the language is, but in a non-public area, that sort of stuff. And I'll get more into that. And then there's the art of performance. Can I talk? Now, even if that BDA is turned up to full gain and causing massive interference to the radio network, you'll still be able to talk. So that's not a good indication of whether or not the system was installed correctly. So we have a checklist. I love checklists. This is in chapter 23 of the handbook. Someone today is going to walk away with that handbook. Otherwise, it is available at versushandbook.com, and you get your own copy. It's well worth it. So when we look through the physical inspection, well, I'm not going to read everything, but was a permit filed? Is the equipment listed to UL? And not just the BDA, but the cables, the listable parts, which is pretty much just the BDA, and then of course you need a plenum rating with this listing on the cable. Pathway survivability. Does it meet the code? Mechanical protection. Is the cable protected where it's exposed to damage? These sort of things. Plenum cable. Is there lightning protection installed? NEC section 810. No, 820. Yeah, 820 talks about lightning protection. Where it should be located? It should be located as close as practical where that donor cable enters the building. That's what NEC says. Okay. But you just want to know, is there a lightning protector? Because IFC and NFPA says there must be a lightning protector installed in the donor coax. Does it have standby power? You want to have a battery backup system. Now there are certain building-wide emergency systems that can adjust either the amount of time or even the requirement. If there's an emergency power system that comes up within 10 seconds, that BDA and the BDA is connected to that system, no battery backups required. So all of this is right in your code books. Proper NEMA rated cabinets. Pretty much if it's a red box, it's UL listed, it's going to be fine because UL verifies the ratings of the cabinet. Is it monitored by the fire alarm panel? So one of the things you want to do there is have the system integrator initiate the alarms. All right, a simple one is a donor fail alarm. The donor test. It may take a couple of minutes, but it should indicate a supervisory alarm to the panel. Disconnect the AC power. Go ahead, unlock that, and unlock the breaker, disconnect the AC. Okay. You should have an AC fail alarm. What you're not going to see, generally there's 12 to 24 hours worth of battery. So if you get a low battery alarm, you'd have to leave it off for too long. So maybe that's not practical. Another important one is RF fail alarm. Best way to do that is have the integrator go in. Usually there's a user interface with a computer and have them disable one of the amplifiers. There's an uplink and the downlink power amplifiers. They shut one of those off. Again, within, I believe it's 300 seconds, an alarm should be initiated in the panel. So those are the alarm verifications that I think are more practical. Right? Okay, do you require a dedicated enunciator? Yeah. NFPA, since the very beginning, has required a dedicated enunciator indicating all of the BDA alarms in the fire control room or wherever you say.
What code is that monitoring? List of points.
It's in both 510 and 1225, 1221.
Those points are listed.
Their design documents verify the mounting of the donor antenna. Code now says the donor antenna must be permanently affixed to the building unless approved by the HJ. If it's on one of those movable sleds, it must have a sign saying don't move it without HJ's approval. Which I don't like that idea because, you know, how many roofers and whatever these guys are actually going to pay attention to that? So permanently affixed if at all possible. And then system testing done. Okay, now RF inspection. Code says that if a building doesn't have coverage natively, let me touch on that for just a sec. Code doesn't say all buildings have to have a BDA. Code says BDAs, your radio must operate in 95% of every floor in a building. So if your radio operates, no BDA is required. There's a test that can be done, a couple of tests. I mean, I'm sure you guys or, draft one of the rookie, firefighters at the local station to go and stand in the middle of each grid and do a voice test. Well, the more practical method is have the system integrator do that RF survey with signal strength or signal quality. Print a nice little pretty report. Oftentimes they come in like red, green squares. And if it's all green or there's only one red square, per floor, they give you that report. What that report is saying is this building passes and it doesn't need a BDA system. Right? Unnecessary BDAs are bad. It's just just another chance for someone to come in and misbehave with their BDA. So if at all possible, we don't want every building having a BDA, only those that need it. All right. Noise floor requirement. That's in the code now. You cannot raise the noise floor at the radio site. We talked about that, what that is. It's hard. I don't expect you to understand the uplink math. That's a tough one. But if you're requiring, that documentation during setup, the plan review, that helps. And then of course, at plan review, you can go to, well, what is their uplink gain in plan review? It's the other thing, if it's at maximum gain at that point, fail. BDAs never operate at maximum gain. The designer should have put in should have calculated his uplink path and set the design, the proper uplink gain and the downlink gain. Okay. Isolation of donor antennas. Again, that's not something you task, but you should require a report from the system integrator. What is the isolation? That's the electrical separation between the indoor and the outdoor antenna system. Okay. Code says it must be 20 dB above system gain. So how do you know? A lot of this stuff is stuff that the system integrator should be providing to you in their report. The grid test, pass, fail. What are the frequencies that are intended? What are the signal levels recorded at the donor? What is the isolation? What are our gain settings? All these things should be in the documentation that's submitted to you prior to inspection. Now, that'd be great. If you see that he's set to 80 or 90 dB a gain, you're going to go on site. All right. Have your department get you a handbook. So there's a lot more to it, but I don't want to run long. I ran long last time. I was doing one of these for Council Rock Microwave, and Vince hasn't talked to me since. All right, supervisory connections. I do have to do, right? Oh, no, that's right, we have Q&A. Well, you'll have 1 minute for Q&A. Okay, I just have a couple more slides. I'm really close. So, all right, so we have fire alarm systems, and code says that the connection from these devices, all devices that are monitored by the fire alarm should be supervised, right? Monitored for whatever their language is. So what most fire alarm integrators do is, they put an end line resistor somewhere when you're monitoring an external device that just gives you a close contact alarm. Well, if that resistor is at that zone module, the addressable module, whatever they call it, and this cable here that plugs into this connector is unprotected, what that means is this is the alarm connector on this particular product. If I disconnect that, will the fire panel ever get an alarm? No. No. And will it know it was just been disconnected? No. No. All right. So what you want to see is either that cable per NFPA 72. It's right in there. All right. NFPA 72 says that I can put the end line resistor here if this pathway is less than 6 feet, 6 feet or less, and protected. Right. So if it's all in conduit to a conduit fitting on the BDA, great. You can put the end line resistor there. If it's not, the end line resistor should go if the alarm contacts in the BDA. And so that's something I think we should watch. Where is this end line resistor? And can its function be disabled? Okay, documentation, designs, coverage, data sheets, spectrum analyzer screenshots, BDA settings, system isolation measurement, measured signal source levels, configuration of the BDA. So these are all things that should be submitted to you when they request a inspection. And with that, I want to thank you, Captain Rock, for having me come in, and thank you for your time. And we have now 2 minutes for Q&A. Yeah. And I see lunch is here as well, but yeah, let's open it up to any questions at this time. Yeah, here you go. Oh, you first.
As far as the electrical inspection, do the electrical inspectors typically know what they're looking for when it comes to BDA?
Generally, I would say yes.
Okay.
Because, a lot of it's just NEC 250, which is grounding, right? So they're going to want to say, yes, this is grounded. It also covers lightning protection. Is the lightning protection, is the conductor to ground appropriate per code, the point it's connected to, and all that sort of fun stuff. Is the plan, if it's cable in a plenum space, plenum rated, that's again.
Okay.
So, no, not really much. Good question. Thank you. Yeah. Yes.
I just want to mention something, Mike, about this morning.
I'm sorry, this is my presentation.
Yeah.
Yes. Go ahead.
I
Sorry.
went over Station 21 early this morning. We've been having a lot of problems, complaints about bad signal. So this morning I was talking to the first officer, and he said, "Okay, we have communication here, but we don't have communication inside that building."
Yeah.
So we need to go back and look into the building to see they have a BDAs in that property, because they're
Yeah.
complaining inside
Right.
the property.
Yes.
Going to
Yeah.
presentation.
So was there a BDA?
I don't know.
You're gonna find out.
We need to find out. We're working together, Douglas and some.
Let's have a just a quick point of conversation.
And there are some
IFC,
new buildings over there.
well, IFC, we generally talk about just this requirement in new construction. It's really clear cut. IFC has a section for existing buildings.
I love it. Yeah.
Okay, that also includes where if the HJ deems a need, shall we say, or whatever the right word is, you can require existing buildings to comply with the radio coverage requirements. So that'd be something you might want to consider in, let's just call them high-risk buildings, right? Either, maybe it's a fireworks warehouse, hazardous chemicals. Of course, we see schools.
That's an apartment
Great
complex. It's an apartment complex. Like
It could
six
be any
levels.
number of things. It's really on you. You have to write within the IFC to say, I want a system, I want radio coverage in this building. Okay. Anyway, with that. Yeah, Paul.
So along with existing buildings, that's been a real challenge.
Oh, it's. Agreed. This is not easy. It makes it even
It's
harder.
one thing, but then actually being able to rate rooms after the fact, I wouldn't say it's impossible, but it's possible.
Yeah, I think that's a really great point, Paul. So you also. There's a practical thing to this, because putting one of these systems in an existing building, especially if it's hard lid. The other thing, like Paul mentioned, is if you don't have, if it's sprinklered and not a high rise, not a problem. You don't need rated pathways.
It doesn't have the rated room.
Then I guess. I don't know the legalities of it. Can you guys say, well, let's never mind that aspect of the code and let's not require a rated room? Because to your point, building a rated enclosure is, after the fact, could be very, very hard. Anyway. Any other? Well, I guess with that, we have snarf sandwiches back here and chips and I don't know, whatever. So let's see.
Drinks in the cooler, water.
Okay, hang on. And then we're starting at half hour? What?
I thought that was done.
Oh, you have another question?
Already, but I went down.
Vince, are we starting at half hour?
Yeah, we'll start back up at 12:30, so between now and then, get lunch, it won't be a working lunch.
Right.
That is, I won't be speaking while you're eating, so if you've got emails to check, voicemails to check, that kind of thing, so, but we'll start right back up.
Yeah.
One-on-one conversation. Done.
Yeah.
No.
Okay,
Good deal, thanks.
all right. Thank you.
No, we left it like.
Go on, Ed.
Yeah, appreciate it. Unfortunately, there's some clock. I know, I didn't notice that.
No, I actually did call, but I got.
I was watching this.
Wound up being, like, I called up the message, he called up the message.